All right, welcome back. Mr. Munyon here again with activity 15-3. Parallelograms, one of the most important ones. So in 15-3, we're going to focus on developing properties and proving properties of parallelograms, mostly developing the properties so that we know how to use them. Proofs are important. We'll use a little bit of congruent triangles to help with that, but our main goal is to know what the properties are. So here we have a parallelogram, question 1. It's a quadrilateral with both pairs of opposite sides that are parallel. So the definition, obviously important, both pairs of opposite sides parallel. In addition to having opposite sides that are parallel, what else do we know to be true about a parallelogram? Well, if you have parallel lines cut by a transversal, we do have consecutive angles that would be let me change the color here. Same side interior angles, so they are supplementary. And that's true for this other pair over here, so these have to be supplementary. And since A and Y are both supplementary to T, they're going to be congruent. And then same thing here, if Y is supplementary to T and K, this one's going to have to be with 2 arc marks as well. So consecutive angles are supplementary. Okay. Number 2 says use 3 index cards and draw 3 different parallels. Whenever you create a diagonal on a parallelogram, that diagonal is going to cut the parallelogram into 2 congruent triangles. And at the center of that diagonal, there is rotational symmetry. So if I was to rotate triangle DIG around that, it would actually map exactly onto. So each diagonal of a parallelogram divides into 2 congruent triangles. So that means like this side here would rotate around to this side, so those sides have to be congruent to each other. This side here would rotate around to this side. Obviously the shared side, G would rotate over to I, and I would rotate over to G. So that third side right there would make them prove that they're congruent there. Question 4 says parallelogram DIG shown. Complete the theorems. Opposite sides of a parallelogram are congruent. And these are theorems, so this is obviously an important property here. Opposite angles of a parallelogram are congruent. And we don't need to prove that they're congruent. We kind of already walked through if A and Y are supplementary to T, then they have to be congruent to each other. That figure got kind of ugly, so I guess I can make it a little bit neater. All right. So we're not going to do the proof for that one or part B. We just need to know these properties. So let's skip these proofs for now. So number 6 here, oh yeah, same thing. We're not going to talk about the things we didn't prove. Number 6 says parallelogram LUCK, here, L-U-C-K, use the figure and the theorems that we just learned about for for the following questions. All right. So A here says triangle KCL. So KCL is congruent to what? Obviously the other one, but we want to make sure that the pieces correspond correctly. So here, I'm going to go ahead and label this angle is congruent to its opposite angle. This side is congruent here, and this side is congruent here. So K does correspond to U. And then from there, it goes across the side with 1 tick mark on it right there. So that means from U, we're going to go across the side with 1 tick mark to L, C. So the order of that congruency statement is important. You can't just pick 3 random letters and throw it in there because it has to, each vertice has to correspond in the congruency statement. All right, for question B, it says, solve for x if the measure of angle KCU equals 10x minus 15. So KCU, this whole angle right here, equals 10x minus 15. And the measure of angle K equals 6x plus 3. So right here, we have 6x plus 3. So how am I going to solve this one? Just looking at them, I can tell they're not going to be equal to each other. This is an obtuse angle here at C, and this is an acute angle. But because it's a parallelogram, I do have parallel lines cut by this transversal, and they are same side interior angles that I have there. So they're going to be supplementary. So I know angle K plus angle, or KCU, has to add up to equal 180. So 6x plus 3 plus 10x minus 15 equals 180. Combine my like terms on there. So 16x minus 12 equals 180. 16x equals 192. And x equals, so 160 is 10, plus 32 more would be 2. Yep, so 12. All right, so x equals 12 on this one, and that's all we were trying to do was solve for x. Part C looks like we need to relabel some stuff, so I'll just use a different color. Maybe we have room to do it without erasing. Solve for x and y if KL equals 2x plus y. So KL equals 2x plus, and LU equals 7. UC equals 14. And KC equals 5y minus 4x. So I know that the opposite pieces are congruent. So the two left and right side, KL and CU, I know that 2x plus y equals 14. I'm going to go ahead and solve for y on this one so that I can use substitution eventually. We're going to have a system of equations we can use. So subtract 2x from both sides, y equals negative 2x plus 14. And for the other equation, the top and bottom have to be equal. So I know that 5y minus 4x equals 7. The bottom is has to be equal to the top. Same thing, I can solve for y here. So 5 subtract or add 4x to both sides. I get 5y equals positive 4x plus 7. And divide by 5, I end up getting y equals 4/5 x plus divide by 5, 7/5. All right, now that I have my values, I can go ahead and substitute in, if I know what y equals here, I can go ahead and substitute it in here, and I'll have an equation with only variable x that I can solve for. I am going to go ahead and erase this other stuff over here. So I'll substitute in here negative 2x plus 14 is going to equal 4/5 x plus 7/5. All right. As usual, I like to get rid of fractions. So if I have a denominator 5, I can multiply both sides by 5 and rewrite this one. So negative 10x plus 70 equals, multiplying that by 5, you get 4x. Multiplying that by 5, you get 7. So now I can add 10x to both sides. And subtract 7 from both sides. And divide by 14. And what is that going to be? So that would have been 5, so 4.5. All right, so x equals 4.5. And I guess we still need to solve for y on this one. So we'll go ahead and plug that into one of the two equations. I could plug it back into this one here, would be the easiest one. So x equals 4.5 and y equals 5. Let's check just to make sure when we plug back in both of these that it works. So right here should equal 2 times x, so 9 plus 5 does equal 14. And here y was 5, so 5 times 5 is 25, minus 4.5 times 4, so 18. So 25 minus 18 is 7, and sure enough, it does equal 7 up there. So when I plug what I got back in for x and y, just to make sure, it does work. So kind of ugly, but we did end up getting x equals 4.5 and y equals 5. Right. Moving on to 7, rewrite the above theorem in if-then form. The diagonals of a parallelogram bisect each other. Okay, so if a quadrilateral is a parallelogram, then the diagonals bisect each other. Okay. It looks like we had enough room on there. For part B, draw a figure for the theorem, including the diagonals. Label the vertices and the point of intersection for the diagonals. Identify the information that is given and what needs to be proven. We're not going to do this proof here as well, but I am going to draw a parallelogram and label. All right, there's a nice one. So it says that the diagonals bisect each other. So if I was to draw the diagonals on this one, let's go ahead and the diagonals would bisect each other. So this one got bisected, so those two are equal. And this one also got bisected. And once again, we're not going to do the proof. We just need to know this theorem. It's important. So what we've got so far is on a parallelogram, opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. A diagonal cuts the parallelogram into two congruent triangles with rotational symmetry. And the diagonals, if you draw both of them, bisect each other. All right, so we've got lots of properties there. Are trapezoids, why are trapezoids and kites not parallelograms? Because to be a parallelogram, it has to have two pairs of opposite sides that are parallel. Okay. For number 9, it says the measure of one angle of a parallelogram is 68. What are the measures of the other three angles of a parallelogram? Well, this one sounds like it might be impossible, but in reality, it's really easy. If you have a 68-degree angle, and we know it's a parallelogram, the opposite angles are congruent, so the other one is 68 here. Consecutive angles are supplementary, so 112 has to add up to 180. So these opposite angles are congruent. So 68, 112, 68, 112 would be all of them. So 112. Number 10 says the length of two sides of a parallelogram are 12 and 18. What are the lengths of the other two? Well, the opposite sides. Oh, that's one we didn't list. Opposite sides are congruent. So the other two sides are 12 inches and 18 inches for this one. All right, here we have some lesson practice. Pause the video here, see if you can answer questions 11 and 12. When you unpause it, I'll have the answers for you. All right, so for question 11, looks like we have some information about the diagonals of a parallelogram. We just learned that the diagonals bisect each other. So this piece here, when it gets bisected, makes two congruent pieces. So let's start with that one. 2y is going to equal y plus 5. So subtract y from both sides, y equals 5. So you get 10 and 10. So AE is 10. EC is 10. And for the other one, we can do the same thing because that diagonal is also bisected. So that blue one got bisected and cut into equal halves. So x plus 1 is going to equal 3x minus 13. So subtract x from both sides, add 13, divide by 2. So we end up x equals 7. So plug it back in. We get 7 plus 1 is 8. And 21 minus 13 is 8. So both of those equal 8. So DE is 8. and EB is 8. Okay, so far so good on that first one. On number 12, it's a parallelogram again. So we know opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary. It looks like what we need to know for this one. So measure of angle W. You could figure out either one of these and use supplementary angles to find W, or if you find out Y, you could use opposite angles are congruent to figure that out. But we need to solve for B to be able to figure out either one of those two angles. So just looking at them, I tell, okay, they're definitely not congruent. This one is acute, this one's obtuse. But because it's a parallelogram, the parallel lines cut by a transversal do make same side interior angles that are supplementary. So I know angle X plus angle Y has to add up and equal 180. So B plus 15 plus 2B equals 180. So combine like terms, 3B plus 15 equals 180. 3B equals 165. So B, right, 55. And we can plug it back in just to make sure. So 55 times 2 does equal 110. And 55 minus 15, or plus 15, should be 60, 70. There we go. So those are supplementary, 70 and 110. And now these opposite angles are congruent as well. So then W will equal 110. X is going to equal 70. Y is going to equal 110. Z is opposite with 70, so those are congruent. WZ and XY, we haven't solved those yet, so let's go ahead and do that one. Opposite sides of a parallelogram are congruent, so 4A plus 10 is going to equal 6A. Subtract 4A from both sides, divide by 2. So we get A equals 5, plug it back in, we get 30. And 20 plus 10 is 30. If 4 times 5 is 20 plus 10, so 30 and 30. So WZ is 30, and XY is 30. All right. This is not the end of the lesson. We still got stuff to do with parallelograms here. Oh, actually, this is the end of the lesson. Great job, guys. Hashtag so proud. You want to see my favorite inequality? 1 is less than Y is less than E. Oh, that's my name. I'm Kyle.